Hi, welcome to Raw Math. Today I'm doing a series of videos on functions. And today I'm doing a graph of a piecewise function. And what that specifically means is we have a single graph made up of two or more partial functions. So when x is less than 2, we're made up of the graph, the square root of x plus 2 and plus 2, lots of 2's. And when we're greater than or equal to 2, we are made up of the graph x squared plus 2. It also says state the domain and range to make things extremely interesting. So I think I normally do a big fat marker, but I think I need to do a smaller pen for this because I'm going to do a lot of work. If I do -3, I have the square root of -3 plus 2 plus 2. So this is going to be the square root of -1 plus 2, but we can't have the square root of -1. So this is not possible. We just don't have anything in there at all. End game. So then, because we're still, this is our cutoff right here. Then we have the square root of -2 plus 2 plus 2, which is the square root of 0 plus 2. Well, that's 0. That's plus 2. This is going to be 2. All right, so then we have the square root of -1 plus 2 plus 2. Well, this is 1, and this is square root of 1 plus 2. So that's 1 plus 2 is 3. Then we have the square root of 0 plus 2 plus 2. So this is going to be the square root of 2. We have enough data points in here that I don't really feel like I need to do all of the, I don't feel like I need to graph all of these data points. This is just to get a feel of what the graph is going to look like. I kind of feel like I could skip up to here because this is going to be rounded and this is going to be rounded. Let's go up to here. So we have the square root of 2 plus 2 plus 2, which is going to be the square root of 4 plus 2. Square root of 4 is 2. 2 plus 2 is 4. I'm going to put a big slash here because I need to do this value for both equations because we don't equal this one. We're going to have to put a circle here. It doesn't equal, but it will equal for the second one. Okay, so for the second one, we have x squared plus 2. So we have, I'm going to do this quickly here, just underneath. For the 2, we have 2 squared plus 2, which is 4 plus 2. So this is going to be 6. And then we have 3 squared plus 2, which is 9 plus 2, which is 11. And then we have 4 squared plus 2, which is 16 plus 2, which is 18. All right, so now we have this table all filled out for all of the bits and pieces that we need to graph. So the -3 doesn't work. And that's because the domain of this graph, the first place that it's valid, is here. This is where the domain starts. So that already tells us a lot about our graph. So we start at -2, 2. -1, 3. And then the next one I did was 2, 4. And that one needs to be an open hole. And that's it for this part of the graph. Kind of looks like a parabola that fell over. And then for our actual parabola, we have 2, 6. And then we have 3, 11, which because this goes up to 10, 11 is just going to be above. And it's going to look like this. This arrow indicates that the graph goes up and up and up and up forever. So if we look at this for our domain, this part of our domain goes from -2 to 2. And this part of our domain goes from 2 to infinity. But because the 2 exists on both of them, they will come together so that the domain is going to be -2 to infinity. I started at -2 because this is a square root graph. There's no arrow on this side. As for the range of this graph went from 2 to 4. And the range on this graph went from 6 to infinity. And because these numbers are not the same, the final range will be 2 to 4 joined with 6 to infinity. So we have a final domain and a final range. The domains could get combined because it was continuous. The range could not be combined because there was a jump in the range. So domain is our x values, our input values. Our range is our output, or y values. All right, I hope you've enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you on the next video. Thanks.